Hello, my name is Zhengfu Chen. I'm currently a PhD student in Agricultural and Biological Engineering Department at Purdue University, working with Professor Kinsey Ambrose and Carl Waskrin. In this video, I will briefly describe the work presented in my recent journal paper entitled Determination of Material and Interaction Properties of Corn and Wheat Kernels for Discrete Element Method Simulations. One critical step in developing a DEM model is determining model input parameters, such as the material and interaction properties. However, there are no standard procedures for evaluating these parameters, and various approaches have been proposed. The common methods used for parameter determination are using values reported in the literature, directly measuring single particle properties, calibrating one or several parameters with bulk material tests, or a combination of the methods mentioned above. The current study aims to determine the material and interaction properties of corn and wheat kernels from literature values, direct measurement tests, and calibration tests. The Young's modulus, Poisson's ratio, and interparticle coefficient of restitution were adopted from literature. The particle shape, mass, particle wall, and interparticle friction coefficients were experimentally measured. The particle wall coefficient of restitution was estimated using a calibration method. Bulk material tests were conducted to validate the determined values. The experiment devices we used to characterize the properties are shown in the slide. An X-ray macro CT scanner was used to determine the shape of the grain. The scanner is able to generate a 3D CAD model of the kernel. Based on the CAD model, an approximate shape was produced using the automated sphere clump generator software. A tribometer was used to measure the coefficient of friction. A drop kernel test was developed to calibrate the particle wall coefficient of restitution. The figure shows all 12 glued sphere clumps used in the current study. For both corn and wheat kernels, the errors between 3D mesh models and corresponding glued sphere clumps are low. It indicates that the glued sphere clumps give an accurate shape representation of the original particle. Other input parameters used for bulk material test simulations are summarized in this slide. To check the accuracy of the measurements, the measured properties shown in the previous slides were used as input parameters to simulate common bulk material tests, including bulk density test and angle of repose test. The simulated results were compared to the real-life experiment results. The results showed that the simulation can accurately predict the bulk behavior of the grain kernels. For bulk density tests, the percent errors between experimental and simulation results are smaller than 10%. For angle of repose test, as shown in the figure, qualitatively the shape of the pell acquired from experiment and simulation are very similar. To make a quantitative comparison between the pell outlines, the images of the pells were processed using MATLAB. The percent errors of the pell head between experimental and simulation results are smaller than 5%. The mean square error between simulation and experimental results are also calculated. In conclusion, the low percent error between experimental and simulated values indicates that the material and interaction properties are accurately measured, and the tests conducted in this study are appropriate for grain kernel characterization of DEM modeling. Here is the link to view the paper. Thank you for your attention.